Hello everyone, and welcome back to DMG. Today we're going to be disassembling this 2TB 7200 RPM HGST Ultrastar from 2010. While I'm taking the lid off, I'll tell you a little bit more about the story behind how this drive died. But before I actually get into the drive, I am going to bring out my HGST drive history video that I made a couple months ago. It's very interesting, and if you're as interested in hard drives as I am, then you might want to go check it out because the history behind these drives is pretty cool, and just seeing the evolution of the chassis. And this is one of the latter revisions of the Ultrastar series. It's before they moved to a design that had this fully sealed off. It still has this air pocket here. The controller board, the chips are still on this side. They were flipped to the other side in, I think it was 2011, 2012-ish. But anyway, let's get into this drive. So this, I was going to set up a RAID array with 3 drives, this being one of them in my workstation. I popped it in, and it didn't work. The array wouldn't format. So I thought, there must be something with like my configuration. So I rebooted, I went into the BIOS instead of doing it through software, and I set it on my SAS controller, and then Windows just stopped booting. So I figured, okay, it probably has to do with this new drive. So I took it out and I tested it, and it doesn't seem to have any bad sectors. Its smart data reports fine, but for some odd reason, it's only reading at 1.3 megabytes per second. It's always at 100% usage, probably because it reads at 1.3 megabytes per second. It's got horrible I/O performance, and about every minute or so, it racks up another CRC interface error. So I figured it's time to go for this drive. It's made it a solid 14 years, which is good for a hard drive. And I will say, I often talk about how reliable these drives are. And because this one died, that doesn't mean every Ultrastar is unreliable. They're still very reliable drives. Every drive is susceptible to mechanical failure. Some are just especially prone to it, and some, like the Ultrastar series, especially the later revisions, are especially resistant to mechanical failure. So, I mean, it's not like I don't trust Ultrastars anymore or anything. I'm going to continue using them. I'm actually going to buy another one of the 2 later revision Ultrastars I already own to run in this RAID array, because I like using hard drives instead of SSDs for video editing and exporting, because in RAID they're quite fast for sequentials. They match a SATA SSD, and they don't wear out like SSDs do. And once I get these out, I should be able to lift the lid. I've never disassembled this exact revision of an Ultrastar, but they're all a rather similar chassis design. If I'm lucky, I can run this drive while it's open, and okay, there must be a screw under here. Yep, there is. So that means we have no central screw on the spindle clamp. My bet is that it's 6 or 8 around the edge. Should be enough to open. Yep, that opened very easily now. And there it is. That's a good looking drive. 1, 2, 3, 4, 5, 6 around the periphery of the spindle clamp. Good lord, that's a lot of platters. 1, 2, is that 5? I may be counting that wrong. It's either 4 or 5. Okay, interesting. So we got a filter here built into the chassis. Usually you see them built into the lid like this one is. So you have a filter built into the lid, the chassis, and up here for the platters. Is that sealed off, that filter? No, it's not completely sealed off. It's just covered slightly. So we have load ramps instead of landing zones, which is always good. Let me grab my caddy. Alright, reminder, don't mess with this stuff unless you know what you're doing. I know what I'm doing. Don't open up your hard drive and then complain to me in the comments how you lost all your data. This drive is dead. Alright, with that said, this thing moves a lot of air. Wow. That's an interesting click of death. It's like a squeak of death. Wow. The amount of air this drive moves is insane. And if I push on the lid hard enough, that's enough pressure for it to start reading. Alright, I'm gonna kill it again. By the way, it's unplugged right now. Here's the plug. So that's just how much momentum these large multi-platter drives have. So it has a very strong motor. I'm gonna put most of my weight on the lid as I power it up. And that should allow it to spin up and read. Okay, I feel it reading. Okay, so as soon as I take weight off of here, it stops reading, which that is pretty normal for a hard drive. That is why those 3 screws are there, to keep the lid super tight on there and to retain tension so that it can function properly. Wow. Yeah, overall, I am incredibly impressed with the overall build of this drive. It is incredibly well made. It's a shame this died. I bet this would have lived for many, many more years. Let's see the size of this magnet and the size of the voice coil, because that's a very large head assembly. Because it has to read from so many platters. So I bet it will be, oh wow, that's a long screw. So I bet it will be a large magnet and a pretty substantial voice coil to move the head. Yeah, that is a huge magnet, good lord. Yeah, this is a server drive, alright. Oh wow, I think that's the biggest I've ever seen. That is very impressive. And we have a small magnet here. Okay, so that explains the head movement we were seeing, why the heads didn't actually move onto the platter until it was fully spun up. There is this locking mechanism that latches to this white plastic piece on the back of the heads that prevents them from moving unless there's, I believe it's unless there's enough airflow going through it. Which is cool. A lot of drives do that. You don't see it as much on drives nowadays, but especially 10, 20, 30 years ago, that was, pretty much every hard drive had that in the, 90s, early 2000s, and high-end drives still have this in the, 2010s. Now, I think with this piece removed, I should be able to slide the heads, overextend them. No, what is holding them? Okay, it's this little rubber bumper. There we go. I'm gonna see if I can get the platters out. These are screwed down extremely tight, so I don't think I'm gonna be able to detach the platters, but yeah, good lord, there are 5 platters in this drive. That is the most I have ever seen in a drive that I've worked on. I've worked on drives with 3 and 4 in the past, but 5. Good lord. That is a big number. It truly is a shame that this drive is gone, because just looking at it, I feel very confident in the ability of my other Ultrastars to last for another 10 years of flying hours. Because, dang, I have 3 other Ultrastars of the latest design, or the later design, the 2012-2014 design, and well, now 4 actually, because I bought a replacement for this drive of a newer design. But yeah, I am very confident in those now. Let's see, is this filter just the charcoal, or is there... Okay, so it has a plastic case around it. Yeah, alright. So that's what this little filter is down here. Again, shame I can't get those platters out. Often with server drives, they're screwed down, well, server drives especially, they're screwed down extremely tightly. And that's a good thing, because you don't want your platters detaching or rattling around or any of that in a server environment where you want your drives to be reliable. It also really helps reduce vibration, but it makes them hard to get off 10 years after the drive is made, when some nerd on a YouTube channel is disassembling them. That's a big motor, by the way. You don't see motors that large on consumer drives. Let me pull off this controller board. We have a typical setup here. A lot of server drives use discrete, or sorry, they don't use discrete, they use all-in-one solutions for controller, cache, and often ROMs, but that's all separate. We have our ROMs up here, we have our controller here, we have our motor control here, and we have our cache here. How much cache do we have? 16 megabytes, it looks like, from the code on the chip, which is about average. That's what I would expect from a higher-end 2010 drive. This is SATA, not SAS, by the way. Yeah, nothing on the back here. We got some nice foam there. Those screws just hold the magnet in the center of the head assembly in. Let me actually take out the head assembly just so I can show you how big it is, because it's hard to get a sense for how impressive this drive is just on the camera. So just to show you how many actual little pieces are on the head assembly, I think that will really demonstrate what I'm trying to get at. Oh, of course, it's a bearing. I can't just turn the screw. That's not how it works. I have to hold it here. I'm sorry that I'm having to do this off camera, but with these, they have ball bearings inside. It's a cylinder with bearings, so unless you hold the other side, you can't get it out. Alright, that should do it. Oops, I accidentally bent some of them, but look at this dang head assembly. There's so many. 1, 2, 3, 4, 5 for each platter. 2 per side of these little arms, which is insane. In the middle, wow, this whole head assembly weighs as much as like some laptop drives that I've held. Like, this is an impressive piece of engineering right here. I'm sorry that I'm just having a nerdgasm over this hardware, but it's just amazing. We have a little piece in the middle of the voice coil here. You do occasionally see that. I didn't expect to see it on this drive, though. Not exactly sure what those are for. Yeah, this is very impressive. I think that's about all I can do, so that's where I'm going to wrap up this video. But thank you everyone so much for watching. Hope you enjoyed the video. Well, actually, hopefully I don't have to do more teardowns in the future, because that means one of my drives died. But if you enjoy hard drive teardowns, Make sure to subscribe and watch the other videos on the channel because I have tons of them. I've been doing this for years. But that's it for this one. Thanks for watching, hope you enjoyed, and see you next time.